will be a lot of interest in these presentations that you are providing, particularly with people wanting to perform their own vector analysis on their own data. Let's discuss the analysis of different procedures using the Alpins method.
Well, I think it's a good idea for people to take it up themselves because it gives them a deeper understanding of it all. So to give you an overview of it, you need to calculate three principal vectors: the SAA, TIA and difference vector. So looking at the TIA first, that is actually the treatment target induced astigmatism vector. The astigmatic treatment is either what numbers you put into the laser, the numbers you put into your nomogram for incisional surgery, or the astigmatic power of a toric implant at the corneal plane. So that gives you a magnitude and an orientation, which is your TIA. Your SAA is the astigmatic change measured by any device. It just has to be the same device post-operatively versus pre-operatively. So it is cornea versus cornea, it's refractive versus refractive, or it's hybrid, which is for a toric analysis, comparing post-op refractive cylinder to pre-operative corneal astigmatism. So that's important to use a refractive analysis or a corneal analysis, and I think it's effective to use both because corneal analysis is based on objective values, whereas refractive analysis is more subjective. So you will find the two analyses are parallel but a little bit different, and often the answer lies somewhere in between the two.
And what does the difference vector tell us?
So the difference vector is the third vector. The difference vector is what is left over in the astigmatism, what have you missed your target by. The difference vector is a very objective means of measuring how much astigmatism is left over in absolute terms. But if you want to relate it to the difficulty of the treatment, then the difference vector is then best divided by the TIA, and that gives you a relative measure of success, known as the index of success. So if you have got a bigger astigmatic treatment versus a small astigmatic treatment, but the same left over, such as the difference vector, then obviously the big treatment is going to be classified as being more accurate.
When analysing hundreds or even thousands of cases, how is the mean of the various parameters calculated in the Alpins method?
Yeah, so that's a good question. When you look at a lot of vectors, you can do a mean magnitude, but if you want to bring the axis into the equation, then you want to do a summated vector mean, or SVM. Some people call this the centroid. So the summated vector mean is when you do a head-to-tail summation of many vectors, and you take the end point of the last to the starting point of the first, divided by the number of components, and this gives you the overall effect of any number of treatments. So the summated vector mean is a very useful number when determining trends, especially when you compare it to the original mean magnitude. Because if the trend is random, you're going to have a very small ratio. If the trend is strong, you're going to have a much larger number, closer to 1.